All right, let's get my screen share. And welcome, everyone. Thank you for coming to my session. My name is Mike Hartington. Let's dive into this. So, first off, I want to point out a pretty awesome fact. At any given moment, I have this amazing device in my pocket at all times. We basically have this incredibly fast computer hanging around, access to the entirety of the internet, um, can do all sorts of crazy and impressive things, can give you access to not only the entirety of the web, but the vast majority of apps that are available out there. Um, and it just sits in your pocket. But humble things, but all great things have pretty humble beginnings. Um, the original iPhone is no exception here. It was a pretty groundbreaking device. I don't think anyone disagrees here in that it brought this whole new concept of mobile to the masses. And fun fact, when the original iPhone was released, the promise was, well, instead of having you learn yet another language or have to create specific apps for the iPhone, we're going to take the power of the web and we were going to use that as our development kit. We were going to use HTML, CSS, and JavaScript to develop these really compelling applications and deploy them. And when users wanted to access these apps or these web apps, they would just go to a URL. Instant sharing, instant access, no having to download another app, and more importantly, not no having to maintain a secondary SDK from the development team. But I think we all know that that did not end up being the situation. We now have things like Swift and historically Objective C on iOS. Android has a similar situation with Java and now Kotlin as a secondary kind of language to write apps for. And for me, this has always been a problem. It's not something I enjoy having to do. I'd rather have this way of shipping apps onto all these platforms without having to learn new tools. I want to go back to that web first approach. And this brings up the concept of cross platform development. This is what we're going to look at today. This is how we're going to look at what is a modern approach to doing mobile and some of the solutions out here, how they solve, and solutions that me and my company have been working on to make this better. So this is a modern web dev's approach to mobile. My name is Mike Hartington. I work for a company called Ionic. You can find me on Twitter or any other social media as M Hartington, first initial, last name. Um, Drop some questions if you have any during the sessions. We'll be able to get to them. But if you can't think of something now, feel free to tweet at me later on. So this cross-platform idea, what are we actually talking about? We're talking about a few things, but most importantly, we're trying to talk about a way to take an app, write it once, and then deploy it to all of these different platforms. We should be able to take an app that can be written in some language, deploy it to the web, deploy it to iOS, and deploy it to Android. And then that can have all the features it needs without having to write a whole bunch of conditionals, right? Without having to have certain parts of our app swapped out. It should just be able to work. At the same time, we should have these abstractions around native features. So that way we're not having to dive too deep into low-level languages and low-level features to get things like, say, file system access or geolocation services, Bluetooth services, etc. One code base, multiple platforms, really driving home that I should be able to take that same code, whatever language and whatever tools are used to write this code. I should be able to deploy all these targets. Because I am a web dev, we're going to be talking about a web app. So that's going to be our kind of core starting point, is a web app. Now, this is a great sounding feature, but this is not the norm. If you go to talk to any developers in large enterprises or in companies that are just getting started out, they're not doing cross-platform for a few reasons. So let's take a look back at why this is the case. So looking back, the original iPhone was released in 2008. The original and its SDK was released shortly thereafter, and then the original Android SDK was released in 2009. So this is over 10 years of native tooling improvements, native improvements to languages, features. Being able to develop a native app has been incredibly powerful these days. You don't actually have to do a whole lot to get something up and running. But developers wanted options. Not everyone is a fan of writing Objective-C. I know I was never. Swift, it's okay, but I want options. I want to be able to reuse my strength, which is JavaScript. Other devs had that same option, and they had created this project called Cordova. If you've heard it before, it's probably also by the name of PhoneGap. The two are just the same name. But they really pioneered this idea of write once, run anywhere. And they're probably one of the first, if not the first. And their idea was to say, let's take all of these cool features that we can do in native and add a web approach to doing this. Let's give people a polyfill for accessing the camera, accessing the file system, and try to help move the standard bodies forward to say, hey, here's like a real world application that's using these features. Here's some of the problems that we're solving and how we're implementing them on these platforms. Maybe we should add, say, a camera API to JavaScript or to the web. And I think with that in mind, their probably most ambitious goal becomes pretty clear. They didn't want to exist forever. They wanted to say, well, the web has gotten good enough. Let's kind of end as a project because we served our purpose, which is a pretty interesting goal to have. Now, architecturally, they're pretty simple setup. They have this web app that gets they have a web app that gets loaded inside of a headless browser, so a native web view. And between the web view and what's called the bridge layer, there is a proxy communication, so that way any call from the web app to the gets emitted from the web view to the bridge, and then that makes the calls to the correct hardware APIs and device features, serializes those results, and then passes them back into the web app. So it's a really simple approach to how data gets sent out and into the web view. Now, the way that this works is that we have this whole Navigator object, and we can attach different objects to it. So in this case, we want to say, let's give Navigator a camera object. Inside of camera, we're going to call getPicture, have an onSuccess and onFailed callback, and then we can pass some options for how we want to do this. Whenever we have those, whenever we call this function, we'll call onSuccess and onFail, and either get an image result, either as base64 string or as a actual file URL, and then on fail, we'll get an error why this failed. If we want to do anything, pretty compelling and interesting right away on startup, meaning if we wanted to start calling these native features, initializing some native capabilities on app startup we unfortunately had this implicit delay of roughly 500-ish milliseconds. As the web view and the bridge layer needed to have like almost like a handshake to say, hey, I'm ready. Are you ready? Yes. Okay, let's go. This delay in what they call device ready was really dependent on your device's speed, your web app size. So 500 milliseconds is a best case. I've seen it go up to 5 seconds, which is, imagine waiting 5 seconds to be able to do anything in your app. It's pretty bad, pretty slow. Now, what Cordova did really, really well was it targeted a whole bunch of platforms. So not only were there, the iOS and Android, but there was also Windows, all of its variants: Windows Mobile, Windows 7, Windows 8. You could target a lot for Windows. Electron and native macOS are now newer features that have been added to the platform, which are pretty cool. They grew and encouraged this huge community of plugin developers to add native features for things like Touch ID or biometric security. And just encourage developers to add these instead of trying to add it all into the core. And they also treated the native build platforms or the native build projects as a diss target. Kind of saying, hey, I don't care about Xcode or Android Studio. Just give me the file that it's going to generate, and I can blow this away and destroy it, remove it from my file system multiple times without having to manage it, which is pretty cool. Less than ideal, though. They used a lot of custom tooling for everything. This predates some of the modern scripts. Instead of using, for web developers, instead of using things like Node and npm, they were using batch scripts and bash and shell scripts inside of, in place of copying assets over. So it was very brittle. The volatile project structure: imagine if you set your build settings, your signing certificates, any entitlements that you need for your native platforms. You delete those projects, you don't necessarily have an easy way to add them back. This leads back to the treating native as a build target or a build artifact. Once you start messing around with these native projects, you are kind of forced to commit them to version control, which you should have done anyway, but it treated that the default experience left you with a subpar project setup, in my opinion. So it wasn't terrible, but it wasn't great. Now, moving from, if we were to think of it as a spectrum, this was one step from web developer to native developer. What about compile to native? This is what I consider projects like React Native, Flutter, where they are one step removed from just a full-on native developer. And this is where they pioneer their approach, specifically with React Native, of learn once, write anywhere, where instead of saying, hey, you should have one platform for one code base for all these projects, they said, no, that hasn't worked. Let's do one abstraction for multiple platforms. That way we only learn the abstraction. And with this concept, they really pioneered the idea. It's like, this is a truly native app. You just learn the abstraction of React Native, and it can work on all these platforms. And so React Native really took this idea and said, okay, we're going to give you abstractions around native controls. So toggles, text, scroll views, what have you, as React components. And then as your app gets deployed, it's going to generate all that UI at runtime, which I find pretty interesting because it doesn't mean that it's truly native. A lot of folks say it compiles to a native app, but it's still a lot of runtime processing, which is peculiar. So architecturally, this is actually not too different from how Cordova works. We have this web app. In this case, it is a JavaScript app. We load it up inside of a JavaScript VM, so Node, V8, or JavaScript core on iOS. And then there is a bridge layer that proxies calls from the JavaScript VM to the device features and to the hardware features and the device features. Serializes those back, feeds it back into the VM. Fairly typical setup. It's pretty much the same thing as Cordova. And then some, sample code for this. Notice all of this is just React code. We have a component here. It's rendering out a view, which is essentially a glorified div. We have text, so essentially our paragraph text. So all this abstraction over the UI has been handled by React Native. And then we use React itself as a paradigm for rendering all this out. If we want to do something like, say, grab a photo or show a full page camera view, we're probably going to reach for something like Expo. And we're going to use their camera package and then include that into our view. So we do have to depend on third-party dependencies a little bit. Expo seems to be the one that is the blessed solution from the React Native team. And yeah, they do pretty good stuff. So what did this do well? Specifically with React Native, it gave you full access to the native project. If there were features that came out, say, in the latest iOS release that hasn't been added to React Native Core, you could get access to those features and expose that yourself. It wasn't difficult to do that, to wire that up and add those features. You were only limited by your ability to code them. The architecture between the native bridge and the then the web app or JavaScript portion of your project was actually a little bit faster because the connections were made before anything was established. So you literally had an instant access to native features before the rest of your app was ready to go. So you could start kicking off native calls, say Bluetooth, file system access, what have you. And I think the abstractions were generic enough that as you start building these things, you don't really need to know anything about where they're going to run. You just need to know that the abstractions will give you all the safety features that you would want. So if you were on a device, for instance, if you were trying to access biometric security and you were on a device that didn't have like a fingerprint scanner or a facial scanner, it would be able to handle the failure of those. It would be able to handle that situation and fall back and give you the proper error. Less than ideal. It's a very specific set of tool set. You're going to need to know a lot of very platform-specific knowledge and knowledge about React Native itself if you want to do any of this stuff. Having to look up the module features of React Native, it's weird. It's got a lot of quirks to it, but comes with any job. You have to have some specific knowledge on a subject. It does give you this uncanny valley of native JS. Like, is this a performance issue in my JavaScript, or is this a performance issue in the native portion of my code? How do I debug any of this? Now I need to know, okay, am I debugging this with JavaScript, or am I debugging this with the native dev tools? It's kind of weird. And then all that kind of, removes any access to the web. If you want, because it's wrapping native controls, if you want to say deploy this as a web app, you're going to need to jump through some hoops to get this to work. Not ideal in my case. This is a non-extensive list. You could go to, you can swap out React Native for Flutter in this case. You could swap out Cordova for some other solution. There is no real perfect solution, but there has to be that, there's that little voice in the back of my head. It's like, well, what can we do better? What is the better way? And I think we've stumbled on that at my company with this project that we've been working on called Capacitor. So Capacitor is a web-centric API and native runtime for deploying an app and accessing native features. It's two parts: a library and a runtime, where you have access to all these native features and can you have this bridge to all these native features, and you can access them through JavaScript. To maintain the projects, build them, and handle dependencies, we're using the native tools, so CocoaPods, Android libraries. And I think it's the right abstraction. We'll look at it in a demo, but I think this hits the right spot of enough power and enough abstractions to get you to do what you need, or to get you to your goal without having to jump through many hoops. Architecturally, we have a web app that is being loaded in a native web view, and there's a bridge layer that proxies requests. Architecture is fairly typical to what we've seen so far. It is similar to Cordova. It is similar to React Native. There is no difference in how code or how native features are handled here. The only difference is that the UI that you're going to be building here is going to be driven 100% by your web app. So you're not getting native controls, you're getting just a web app. I'm going to show a demo of an Angular app, but you could swap this out for something like React, Vue, no framework at all. Totally possible. But with an Angular app in this case, we're going to see how Capacitor can take your app, deploy as a progressive web app, as an Android app, and also as an iOS app. So before we dive into it, just some things to make sure that you are aware of. Bring your own components, so your framework and library. Capacitor has no strict library that it forces you to use. It is just JavaScript. You can use whatever library or framework you are comfortable using with. If you've done anything with, say, native file system features that exist today, or camera access, you're going to notice that the APIs are not 100% the exact same as the web standards. This is so we can make sure that the abstraction stays generic enough. And yeah, we have instant access to native features. So without spending more time on stuff, let's actually just go ahead and look at a demo. So I'm here in my editor. I have an app over here, and this seems very, very dark. So let's do the light mode today. So I have this app over here. It's like a little note taker app. I should be able to edit some notes and then save them to my file system. So I don't have anything set up for this. So let's go ahead and start adding these features. I'm going to open up my editor. I have a UI layer here. I'm happening to be using a framework that my company also builds called Ionic Framework. Again, we're using it with Angular. You don't need to use any of these. You can if you want to get some pretty good UI, but you could use whatever library or UI library and framework you are comfortable with. All that I need to know is that I am trying to render out a list of notes here in my app. So let's go to my class here. And first, let's kind of start off by saying, well, let's figure out what we need. Well, first, we need to import this file system access. I'm saving all these notes to a file system here in my browser. I need to access the file system, and I'm also going to grab this directory enum, so that way I can have some type-safe way of traversing the file system. With this done, we're going to come into one of our lifecycle hooks. And most importantly, we're going to request permission for accessing the file system. Now, this is pretty important because if you try to access some of these features without requesting permissions, one, your app's going to get rejected. But two, you're going to leave your users in a weird situation where they're like, wait, what just happened? Why is this accessing these features? I didn't say it should. So we can get the permissions to do this pretty simply by just saying, hey, file system, request permission. It's using async await. It's using promises here, so we can have some asynchronous actions. With this here, we can come in and set up the our way of reading from a directory, making a directory. We can set up our file system actions. So we're going to make a directory if it doesn't exist. And then we're going to read that directory if it does exist. So how do we do this? Let's take a look at the make directory function. So make directory is a promise. So again, we're using async await here. And we're just going to call file system.makedir. Make directory, pretty simple naming. Hopefully this feels pretty familiar. We're going to limit this to the documents directory, and the folder itself is going to be called notes. So already we're giving us, we're having the correct way of sandboxing this file system access to a specific location, and it's going to be giving it a specific directory called notes. So this is our make directory function. What about redirectory? Well, redirectory is just going to call file system redir. Fairly simple naming here. We're going to give it the sandbox location that we want to access, and then the actual directory that we want to access. Then to wrap it up, we're just going to do a quick little sort here to sort all these names. And we're just going to say file system sort. So this is fairly easy, pretty typical. If we were to write this, we already have some notes being loaded up into our app. We could read our notes here. There's nothing written in this one, nothing written in this one. Well, there's nothing being written in these notes. Obviously, we have an error in our second part of our app. So let's go to the actual component for this. And again, we're going to begin by importing our file system. We're going to get access to the directory enum. We're also going to get access to the encoding enum here as well. This way, we can obviously write files to the file system in a way that makes sense to modern operating systems. So from here, what we want to do is we want to come in to, on our lifecycle hook, say, hey, if we have a file system name, let's try to read it. So we'll say file system, read this file. Give it the path, the directory that we want to look in, and then obviously the encoding, because we might not want to use UTF-8. But this is what we're going to get. So we can see, import encoding. Oh. 8-bit UCS transformation format. So we basically have the standard kind of formatting and encoding for all this data. So this is good. We're reading a file from the file system. What's the save function here? So in the save function, we're basically saying if we are editing a file, just write the file. But if we don't have a name, or if we're giving this a new file, or we're writing a new file that doesn't have this, come over here and just prompt the user for a name and then write this file. So what does write file do? Well, write calls file system.writefile. We give it the path again, some content, either the content that we are writing in the current note or an empty string, the directory that we are sandboxing to, and then the UTF, and then we call dismiss on the UI or the editor instance. If we wanted to delete a file, we can come over here and say delete file, again, from the file system class, path, directory, and then dismiss the UI. So already we're at this really good point where we can start to write files, delete files, read them from the file system, and read full directories. So let's go ahead and save this and see how this looks all together. So if we remember, this was our first note. We have hello world here being printed out. The actual editor instance doesn't really matter, but for just to make sure you're all aware, this is something called Quill.js. I just happened to find it on the internet. That's giving me the rich text editing. But all this is just saying, hey, let's add all these text features, and let's click save. Now, if we go back to that note, we can see that all those changes are persisted. They're saved to the file system. If we were to say, let's delete this, well, now we've lost that note. So let's go back and add it again. We'll say, hello world, select, let's H1, save it. Okay, what do we want to call this? We're going to call this my note save. And then we have this note already saved. We can access it again. And we have all the file system operations working. And this is just in the browser. Let's go in and actually add these features to our native app. So I'm going to come over here. We're going to end our little dev server. I'm going to do a quick little build of the app. And this will just take a minute. We're basically just running Webpack. And again, this is an Angular app, so we're running the Angular CLI. It's just going to do a quick build of the application itself. Shouldn't take too long. Perfect. And then we can run npx cap run iOS. To copy the assets. Notice that we already include some of these features. So file system, access to the keyboard, to the haptics engine on your device. And then we're prompted to pick our deployment target. Because I don't have my phone connected at the moment, we're just going to deploy to this iPhone 12 simulator. It's going to call the native build tools here, Xcode build in this case. And it's going to deploy it to our simulator. So I already have the simulator up and running. Now we have the app running. We can go in, we could say, hey, let's write a note here. Say hello, save. What would we like to call this? My note, save, and it's already saved to our file system. We could edit this again. And have all this works. So all the apps and all the features to the file system are persisted there. But what if I want to, say, make some changes to this? Well, we actually have this really nifty tool built in here where we can say cap run iOS -- live reload -- external, basically letting us do a live reload build to our simulator here. So let's go ahead and pick the right simulator again. It's going to copy all of our assets. We're just going to set it up to use the right IP address. And it's going to start our dev server for us. Now, this does take a little bit longer, but it doesn't take too long. So we're already running our iOS sync. We're deploying it to the target. We'll eventually see this reload real quick. Cool. Our app is up and running. Let's go to the home page real quick. Let's say we're going to call my notes. We'll say some notes instead. And then because this is an UI library with large titles already built into the framework, we can change it in two places. Save, and then the UI is automatically updated. So you can instantly have this really nice feedback session of being able to write files, save them to the operating system, and have all of this just work. So we got a pretty good flow here. If I was on Android, I could deploy this to Android as well, but my current Android operating setup is needs some maintenance at the moment. So we're not going to try to do that. So let's get back to the slides though. So we saw the demo. We saw some of the cool things that we can do with it. Where else can we deploy this app? Well, we've already seen the iOS. I mentioned that we have Android support as well. And we already saw that we could deploy this as a web app. I could do my quick little build, deploy it to any of the hosting providers I'm used to using, say Firebase hosting, Netlify, Vercel, your own hosting provider if you are doing that. And the app would still work and was still able to access all those features. We currently have Electron in a community incubator. So it is being developed by our community members. They are testing it out. It's currently in release candidate. So pretty soon we'll be able to have Electron support fully baked in and in a good position to be using it for apps. So if you are someone who needs a native desktop equivalent of an app, Electron's there for you. I think we have an aggressive version support, or I don't think we have it, but others have said it's aggressive. We support Android 5.0 and up. Sorry for the 2% of people who have an Android 4.0 device or 4.4 and below. We don't want to support that. It's holding native back. iOS, it's basically whatever the current stable version is -2. So right now, current stable is 14. So that means we support 14, 13, and 12, which gets us pretty good coverage on iOS. If you would like to start a project now and try to get this going, you could add it to your project by just saying npm install at Capacitor core and at Capacitor CLI. That's going to give you access to the core libraries and the CLI tooling to be able to add platforms, add projects, basically get you up and running with Capacitor in your project. Obviously, make your own little branch, practice good version control. And then once you want to start a project and initialize a Capacitor project, you can use tools like npx to run cap init, and that's going to initialize the Capacitor project in your web app. This could be for JavaScript, regular JavaScript project, a Angular projects, what have you. And yes, it is framework agnostic. I know I have said this already, but it's important to note that we are not trying to dictate how you use or how you build your web app. Use whatever you are comfortable with. Use Svelte if that is something you are interested in. Use Angular if that's what you're interested in. Use React if that's what you want to do. I say you should be using one of these. I don't care which one you do use, and neither do we. So, parting thoughts real quick. Capacitor, I think it is the right way to do cross-platform at this point. The abstractions are generic enough. The code that we use to access the file system doesn't know what platform it's on. It can swap out its implementation under the hood without you even being aware of it. The framework agnostic part of it is probably its best call. We are not tied to just one particular framework. Use it with whatever you want. We have people who are using it with no framework at all and using it with tools like lit-html to build out their UI and have a native web component-driven mobile app, which is pretty interesting. And then we have people like me who use a full-fledged framework and can build some pretty cool stuff as well. Point is, try it out, have some opinions about how you're building your app. Capacitor can help you along there and help you reach not only just the web, but also iOS and Android and get access to these native features. So at this point, thank you so much for coming by. If you have any questions, please put them in the chat or into the little Q&A. Happy to go over them. Again, if you want to reach out, Mike Hartington, M Hartington everywhere on Twitter. Thank you so much. Let's take a look at what we got for we have any chat. Oh, awesome. We have a great question. Have you experienced with cross-platform apps which have deep dependencies on OS-specific features like handling Wi-Fi connections, Bluetooth connections, drawing graphics? Um, yeah. Okay. So I don't know if we can actually show this, but yeah, we can actually show this. So deep OS specific features. So yes, we actually have a plugin for doing things like Bluetooth Low Energy and Bluetooth in general in Capacitor. I didn't touch on it here, but we have this full companion project called Capacitor Community. And in fact, let's just go ahead and open this up. So here, I'll drop it in the chat. Close that. Vitus, this entire community organization here in GitHub has access to all these more OS specific features. So we have a Bluetooth one, we have secure connections and Wi-Fi data. I think Wi-Fi is actually built into Capacitor using the network features. And encrypted storage using Keychain is also in the community organization as well. I would say check it out. See, most of these aren't going to be something that you could support on the web, just because the nature of how these features are. But you could definitely have them for both iOS and Android. So, yeah, great question. Jacques Tamer, what are some advantages, disadvantages versus something like Expo? I think the main advantages would definitely be familiarity with the tool. If you're someone who is just familiar with web development and not necessarily the very specific feature set that comes with React Native and Expo in general, you might not want to use that, or you might not feel comfortable using that. Capacitor, in its sense, is fully featured. It's fully web development, so you're not having to learn yet another approach to how to do things. You're just reusing those existing skills. Disadvantages, I would say, I honestly can't think of any disadvantages at the moment. I do think that it probably is some difference in approaches. Like Expo definitely might have a few more plugins under their core. We've just happened to move most of the things that we don't think makes sense in core to the community organization. So Expo, while it might just throw everything in its core library, we have a very slim subset of features that are supported in the core. And then we put everything else into the Capacitor Community Hub. So if you wanted to see what features are part of core, you could go to capacitorjs.com, go to our plugins, and we have a list of the official plugins that are part of our core library, more or less here. All right, we have like one question left, real quick. Any performance differences with performance difference? No, if you're writing a very fast app or if you're following best practices, you're going to have a good performing app regardless. So performance is not so much of an issue. Thank you all for the questions. I am basically out of time, but thank you all for attending. Again, feel free to reach out on social media if you have any questions. Take care.